In this lecture, let's look at the application question for the law of sine. This question says that it has been determined that a communication satellite, in sky, is straight above the extension of line AB. And here is A and here is B. It's straight above this line. Okay. Now, the elevation angle from point A is 88.9 degrees. Okay. So down here is that from this point A, then is 88.9 degrees. And then the elevation angle from point B is 86.4 degrees. So from this point is 86.4 degrees elevation angle. So one is this angle, another is this angle. Alright? Now, if the distance between points A and B is 689 kilometers, we know the distance between A and B is 689 kilometers. And then we want to know what is the distance between the satellite and the point A. So we want to find the distance between the satellite and this point. We know the distance between A and B. We want to find the distance between S and A. Here it says ignore the curvature of the Earth. Here the distance is 689, so it's a kind of curve, but we think this is a straight line. Okay? Yeah, because the Earth is very big. It might be an arc, but we say here, ignore the curvature of the Earth. Means we say from A to B is a totally horizontal. So we want to find the distance between S and A. Now look, the supplementary angle of elevation angle from point A is what? This point, this angle is 88.9, then this angle is 180 minus 88.9, which is 91.1 degrees. So you may put what? You may put 91.1 degrees. Okay? Now, in this triangle, in the triangle SAB, this triangle. So we know this angle is 91.1 degrees, and we know this is 86.4 degrees. Then of course we know this angle. How big is this angle? This angle is 180 degrees minus those two angles. So it's 180 degrees minus angle 86.4 degrees minus 91.1 degrees, which is 2.5 degrees. So this one is 2.5 degrees. Alright? Okay, now we know in this triangle then all the angles, the measures of all the angles, 2.5, 86.4, and 91.1 degrees. We know this side We know this side. Then how are we going to find out this side? So we got to use the law of sine. Okay? Yeah. Look. SA, this length, SA, over sine 86.4 degrees. This stands for angle B. Angle B. Angle B is this, 86.4. So side over sine 86.4 equals what? Equals side AB over sine 2.5 degrees. 2.5. This one stands for angle S. Okay. All right. Now we know SA over 86.4 degrees equals 689 over sine 2.5, because we know again AB is 689 kilometers. And then this one is done on denominator. Denominator, then we want to eliminate this denominator, so we do both sides multiplied by sine 86.4. Then you may cancel this one with this one and let SA stands alone on the left. And then 689 times sine 86.4 divided by sine 2.5 degrees. Okay. And then if you put into your calculator, it's going to be 15,764.5 kilometers. Okay. And down here is, you can approximately write, that's 16,000 kilometers. There are two things I want to point out. Okay, in the law of sine, you see this sine is numerator, this side is denominator, the length of the side. And here I wrote, in a different way. I wrote the angle, sine angle is down below, sine of the angle is down below, and the above is the length of the size. Okay, so this is slightly different from the law of sine, but still works, because if you put angle, this angle on the top, then this one on the top, that's the law of sine. But if you put angle, all the angles below, all the sine are below as a denominator, then all the sides can be upstairs as a numerator. Okay, that's one thing, because I just want to simplify those steps. Okay, I know both sides multiplied by sine 86.4, they will cancel each other, and then SA will come out. That's one thing I want to point out. Another thing is that when you calculate 86.4, you want to make sure your calculator is in degree mode. Okay, is in this mode, not in radian mode. Okay, if you put it in radian, you won't get this answer. All right, so make sure that you may have a different calculator, but make sure your calculator is in degree mode. Then you should be able to have this answer and finally this answer. Okay, yeah, and please review this lecture. I'll see you next time.